start with chapter 1, volume 1 of class 12, that is relation and functions. That is relation and functions. And girls, if you remember, we did in class 11th chapter 2, that was, again the name was relation and functions. Alright, where did we end that chapter? We are going to start this chapter from there. Alright, but we know that the gap is more, so little recapitulation what all we did in class 11th. Alright, first of all we are going to pick up the topic relations and then functions, and then we are going to cover the concerned terms related to all these. So first in relation, we'll start first of all relations, but for relation what are the basic concepts which we did in class 11? A recapitulation of that. First was order pair. Let A and B be two non-empty sets. The element AB is called order pair. Is called order pair. Is it clear? This is called ordered pair. Basically we write ordered pair is called ordered pair. Alright, fine. So it means when I say ordered pair, pair means two. Order means the order is very important. The order is very important. This is the first element. This is the second element. Alright. The order is important. That's why the order pair AB is not equals to order pair BA. Order pair AB is not equals to order pair BA. Irrespective in sets, what used to happen? A set AB can be equals to set BA. That's not a problem. Set AB is equals to set BA, but order pair AB is not equals to order pair BA. Number 2, if two order pairs are equal, if two order pairs are equal, it implies that both ways the first element is equals to first and the second element is equals to second. This all we did in class 11th. Is it clear? Order pair means the order of a pair, where the order is very, very important. Is it clear? I hope order pair is clear to everyone. Now the next what we did in class 11, that was Cartesian product. I hope you all remember. Remember Cartesian product. Cartesian product means let A and B be two sets. Cartesian product is represented by A cross B. A cross B means, Cartesian product means it is a set of all the order pairs where first element belongs to first set and second element belongs to second set. I hope all remember. अभी तो आना शुरू हो गया तो दिमाग में what we did in class 11. It is a set of all the order pairs where first element belongs to first set and the second element belongs to second set. Is it clear? Like if I have A as say 1, B is 2, 3. A cross B will have the order pair which first element belongs to first and second with second. That means 1, 2, 1, 3. Alright, 1, 2. The first element should be from the first set, second element should be from the second set. Few notes for that. That also I am recapitulating once. A cross B, the Cartesian product A cross B is not equals to B cross A. A cross B is not equals to B cross A. See, this is A cross B I have found. Let's find B cross A. The first element should be of the second set. So it will be 2, 1, 3, 1. So both the elements are not equal. A cross B is not equals to B cross A. Is this clear? Alright. And number 2. If A cross B, see all these things can come in MCQs also. Related to relation definitely. If A cross B is a phi, if it is an empty set, it means it is empty if A or B or both are empty. Clear? A or B or both are empty. Is it clear to everyone? Alright. Fine. A and B are empty sets if A or B or both will be empty. Is it clear? So alright. So A cross B is phi because there will be no order pair belonging to A cross B. There will be no order pair belonging to A cross B. Now the third point. Number of elements of A cross B is always equals to number of elements of A into number of elements of B. Is this clear? So it means similarly, number of elements of B cross A will always be equal to number of elements of B cross number of elements of A. If we are talking about the same set, it means number of elements of A cross B will always be equal to number of elements of B cross A. It means literally both the sets are not equal, they are equivalent sets. Alright, they are equivalent set. A cross B and B cross A are not equal sets, they are equivalent sets. Is it clear? They are equivalent length sets. Clear to everyone? Alright. Now, clear? Alright. So same way we can write down the triplets also. We can write down the triplets also. If they ask me A cross B cross C. So that is clear? A cross, A belongs to A, B belongs to B and C belongs to C. So this was all about your Cartesian product. Now coming to relations. What the definition, basic definition, what is a relation and few related questions we did in class 11. So I'll just recapitulate that because in class 12 our topic starts from types of relation. In class 12 our topic starts from types of relation. So first of all, relation. What does relation means? In literal means relation between two things. Suppose relation between me and you. I am your teacher. So we have a teacher-student relation. Is it clear? We have a teacher-student relation. So in literal means, the relation means relation between two things. It can be equals to, greater than, parallel to, because we are talking about mathematical relations. Is it clear? Alright. Otherwise, general relation is a sister of, brother of, father of, mother of. So relation can be any between two persons. But we deal with mathematical relations. Clear, children? Alright. So what was the definition of relation? Relation that A and B be two non-empty sets. Relation. How do we write? Relation is from set A to B. We write like this. R. Relation is denoted by R. R is from set A to B. What is R? R is a subset of Cartesian product. R is a subset of Cartesian product. That means when I write Cartesian product, from Cartesian product I have to pick up those order pairs which satisfy the given relation. Alright, so R is a set of order pairs where A is related to B under some specific relation given to us. Suppose it is equals to, the relation is given equals to. So I'll pick up all those elements and set as natural numbers. Fine. A is also natural number, B is also natural number. So I'll pick up the elements. Relation will have the element 1, 1, 2, 2, 3, 3, 4, 4 because relation is equals to. Did you understand? I'll just give you an example. Suppose the relation is from n to n. natural numbers to natural number, and R is defined as is equal to. So R will have all the elements of first set which are equals to second set. 1 1, 2 2, 3 3, and so on. Understood? So relation means it is a set of order pairs, because it is a set of A cross B, Cartesian product. Because Cartesian product में तो बहुत सारे elements आएंगे, A cross A 1 1, 1 2, 1 3, 1 4 पहले infinite, फिर 2 के साथ combination, फिर 3 के साथ combination. But when the relation is equal to, that means I have to pick up only those order pairs which satisfy this given relation. Understand? Which satisfy this given relation. So relation is always from one non-empty set to other non-empty set. The first non-empty set is called domain. Domain. That means what is domain? If I talk about from the order pairs. So again, remember domain and range. Set A is called domain. Domain set. Is it clear? Set A is called domain set and set B is called codomain. Set A is called domain. A is called domain of R, and this B is called codomain of R. This is domain of R, codomain of R. Is it clear? You remember one word was range also, so we'll write domain and range again. Let R be what is domain? Domain is the set of all the first components of order pairs belonging to R. Of all the order pair belonging to R. Is it clear? इसका मतलब R में जितने भी order pairs आएंगे उसके first elements को, the first component, the first element of each order pair is called domain set. Is it clear? That is a domain. Understood? Clear? If I have, suppose one example we wrote 1 1, 2 2, 3 3, 4 4, 5 5. So the domain is the first elements 1 2 3 4 5 6 and so on. And what is range? Range is set of second component of all the ordered pairs belonging to R. Range is set of all the second components of all the order pairs which belongs to R. Codomain is क्या? Set पूरे set B को codomain बोला जाता है. And range comes from codomain. Range comes from codomain. That means if there is a relation, you remember this arrow diagram also? Relation is from A to B. So this is called domain. This is called codomain, and the range comes from here. The range comes from here. जो element यहाँ से सिर्फ components में pick किए जाएंगे order pairs के अंदर, that is range. That means codomain means the first elements of first set. Codomain means complete second set is called codomain, and the range is the second components of all the order pairs which belongs to R. Is it clear? This was all drills which we did in class 11th. We did order pair. I hope it's clear to everyone. We did Cartesian product. Then we did relation. What is relation? It is a set of order pairs. It is a subset of A cross B where every element, first element satisfy the given relation with the second element. Is it clear? Then we did domain and the range of relations, where domain means the first component of every order pair which belongs to R. Range means the second component of every order pair which belongs to R. Is it clear? I hope all these basic concepts which we did in class 11 are clear to everyone. Let's start with the topic which is there in your class 12, types of relation. Types of relation. Before that, this also you did in class 11, number of relation. If set A has m elements and set B has n elements, then relation from A to B. So number of relations from A to B would be 2 raised to power mn. I hope you remember 2 raised to power mn. Alright. Now the first is types of relation. First we have identity relation. Identity relation. Alright. A relation R in set A in set A. When I say in set A, I am not naming the other set. It means R is from A to A. दोनों set A ही है. Is it clear? The first set is also the elements will be picked up from A. The second elements will also be picked up from A. A relation R in set A is said to be identity if what does it mean? If R has all the order pairs which are of this sort. AA, only AA, that means every element of A is related to itself only. This is very important. It is related to itself only. That means एक एलिमेंट का सिर्फ खुद के साथ रिलेशन है, जो भी रिलेशन दे रखा है अगर वो सिर्फ खुद के साथ सेटिस्फाई करता है तो ऐसे रिलेशन को बोला जाता है आइडेंटिटी रिलेशन. Such kind of relation is called identity relation. Alright, like if suppose relation has such kind of order pairs, only this kind of, it will not have 1 2 1 3 1 4. The element is related, जो भी relation दे रखा है. For example, equals to. So equals to the element will be equals to itself ना, तो उसमें तो सिर्फ ऐसे ही order pair आएंगे 1 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8. Alright, when an element is related to itself only, then it is said to be an identity relation. Is it clear? It is said to be an identity relation. Understood? Clear? Now second we have universal relation. Second we have universal relation. What is universal relation? A relation R in set A is said to be universal relation if every element of set A is related to every element of set B. That means, what does it mean? Universal set if each, better you write here each element of set A is related to every element of set A. अब यहाँ पर by chance both the sets are A, otherwise each element of A is related to every element of set B. ठीक है? अगर हर एक element every element is related to, each element is related to every element of set. That means, for example, I have A is 2, 3. And relation is from A to A. That means यहाँ भी 2, 3 है. Clear? So 2 should be related to 2 also, 2 should be related to 3 also. This 3 should be related to 2 also, and 3 should be related to 3 also. That means each element of first set is related to every element of second set. Each element of first set is related to every element of second set, then it is said to be universal relation. That means R has all the order pairs 2, 2. Because second place में तो आ रही है 2, 2, 2, 3, 3, 2, 3, 3. Fine. Then it is said to be a universal relation. Each element of first set is related to every element of second set. Then we said this is an universal relation. I hope it's clear to everyone. Now the third we'll pick up. Third I'll pick up. That is void or empty relation. A relation R in set A is said to be empty if no element of first set, is related to any element of second set. If no element of set A, the first set है, is related to any element of second set of, so there is no relation. There is no relation. Is it clear? Then we say, and phi is also a subset of A cross A. That will always remain. R is always a subset of Cartesian product. Is it clear? Phi is a subset of every set. Clear? Alright. So that means when no element of first set is related to the second set, then we say it is a empty set. For example, the set is like of all the girls of our school. Alright. And the relation is brother of. That's not possible. No girl is a brother of other girl. Is it clear? So that will be an empty relation. I hope it's clear to everyone. So this void relation is called the smallest relation between two sets, and which we did universal. The universal is called the greatest relation between two sets. Is this clear? The void set is called the smallest relation and universal set is called the greatest relation between two sets. Alright, clear to everyone? Now the next we have fourth, inverse relation. And now inverse relation you will be able to understand when there are two different sets. A set, a relation from set A to B. There is a relation from set A to B. If R is a relation from set A to B, then the relation from set B to A is defined as the inverse relation. If set, I'll just rub this. If R is a relation from A to B, then a relation from B to A. That means अगर R है A से B से, A to B, the relation R is from A to B. अगर B to A पे relation हो जाए, then the relation from B to A is said to be inverse relation. And it is defined as R inverse. It is defined as R inverse. If R is a relation from A to B, then the relation from B to A is said to be inverse relation, and it is defined as R inverse. For example, if I have R has the order pair, say 1, 2, 1, 3, the R inverse will have the relation order pairs. Clear? The inverse of R. The inverse of R. Clear? So what happens? The domain of R inverse is a range of R, and the range of R inverse is a domain of R. That's a relation. Range it's reverse, no? So all these things can come in MCQs. For example, they give you the domain of R and they ask you the range of R inverse. So you should know domain of R and range of R inverse both are equal. Is it clear to everyone? Alright. Fifth is now these three relations which we are going to do, very, very important. The questions would be coming based on this. Reflexive. These three very important. All the questions will be based on these. Reflexive relation. Reflexive relation. A relation R on a set A that means A to A is said to be reflexive, if A is related to A. If A is related to A, that means R has the order pairs of such kind. That means every element is related to itself also. Just girl, mind this. When we did identity, I said every element is related to itself only. Here I am saying every element is related to itself also. एलिमेंट अपने से भी रिलेटेड होना चाहिए, किसी और से भी रिलेटेड हो सकता है. आइडेंटिटी में वो किसी और से रिलेटेड नहीं हो सकता. इट शुड हैव ओनली 1 1 2 2 3 3 4 4. बट रिफ्लेक्सिव क्या है? R can have such kind of elements also. If it is 1 1, it can be 1 2, it can be 1 3, then 2 2. All right, 2 1, 2 2, 2 3, maybe 3 1, 3 2, 3 3. रिफ्लेक्सिव के लिए ये कंपल्सरी है कि एलिमेंट शुड बी रिलेटेड टू इटसेल्फ ऑल्सो, बट इट मे बी रिलेटेड टू अदर एलिमेंट्स ऑल्सो. बट आइडेंटिटी में क्या है? इट शुड बी रिलेटेड टू ओनली इटसेल्फ. दैट मीन्स एवरी रिफ्लेक्सिव रिलेशन कैन बी आइडेंटिटी रिलेशन, but vice versa is not true. Vice versa not true. But every identity relation should be reflexive. Oh, got it wrong. Every identity relation can be reflexive, but every reflexive relation is identity. That is not true. All right. Every बिकॉज जो आइडेंटिटी है उसमें अपने 1 1 वाले एलिमेंट्स तो आएंगे ही आएंगे. आइडेंटिटी रिलेशन कैन बी रिफ्लेक्सिव रिलेशन, बट रिफ्लेक्सिव का आइडेंटिटी होना कंपल्सरी नहीं है, बिकॉज ये रिफ्लेक्सिव के अंदर 2 1 वाले एलिमेंट्स भी हैं, तो वो आइडेंटिटी नहीं है. आइडेंटिटी है 1 1 2 2 3 3, तो वो रिफ्लेक्सिव हो सकता है. Is it clear? But every reflexive set element relation is identity. That is not true. That is not true. Is it clear? All right. I hope it's clear to everyone. So universal relation on a set A is always an identity. Reflexive. All right. Let's pick up the next one. Sixth is symmetric. A relation R on a set A is said to be symmetric if AB belongs to R, lies that BA also belongs to R, where A and B belongs to A. Alright, it means अगर R के अंदर 1 2 एलिमेंट है, तो अगर उसमें 2 1 एलिमेंट भी है तो वो सिमेट्रिक होगा. दैट मीन्स अगर A has a relation with B, if B also shares the same relation with A, then it is said to be symmetric. A जो B के साथ रिलेशन शेयर करता है, अगर B भी A के साथ रिलेशन शेयर करे, then we say it is symmetric. For example, there are 2 girls. Alright, A is a sister of, say Komal is a sister of Payal. Alright, then Payal is also a sister of Komal. So when the 2 elements share the same relation, A share relation with B, B also shares the same relation with A, then it is said to be symmetric. Is it clear? That means जब order pair की form में if I see अगर set के अंदर 1 2 है and it has say 1 1 1 2, there's 2 1 2 2. If the set has element 1 2, it should have 2 1 also. अगर उसमें 1 3 है तो 3 1 भी होना चाहिए, अगर 2 3 है तो 3 2 भी होना चाहिए. जो रिलेशन A B के साथ शेयर कर रहा है, अगर B भी A के साथ वही रिलेशन शेयर कर रहा है, then it is said to be symmetric relation. Then it is said to be symmetric relation. And the last one, transitive. Transitive means a relation R on a set A is said to be transitive if A has a relation with B and the same relation B shares with C, and if A also share a relation, the same relation with B, C, then it is said to be transitive. That means transfer हुआ है. A, there are 3 girls. I said Komal, Payal and say Vanshika. Komal is a sister of Payal. Payal is a sister of Vanshika. Then automatically Komal is also sister of Vanshika. Then we say it is transitive. Is it clear? It is transitive. A जो B के साथ relation share कर रहा है and B is sharing some relation with C. So अगर A भी C के साथ वही relation share करता है, then we say it is transitive. Then it is transitive relation. Is it clear? All right. So that means if in the talk about the order pairs, if I have 1 1 1 2 and then I have 1 3, I have 2 1 2 2 2 3 3 1 3 2 3 3. Means for example, if I say 1 shares a relation with 2, 2 shares the same relation with 3. If 1 shares the same relation with 3, then we say it is transitive. A B के साथ जो share कर रहा है, B C के साथ वही share कर रहा है. अगर A और C में भी वही relation हो जाए, then we say it is a transitive relation. Is it clear? Then we say it is a transitive relation. Now this is very, very important how this question would be asked. It is asked, we have to prove in the questions equivalence relation, the last one. What kind of questions do we get? They ask us, check whether the given relation is equivalence relation or not. Check whether the given relation is equivalence relation or not. Equivalence relation. Equivalence relation. Alright? A relation R on a set A is said to be equivalence if it is reflexive, symmetric, and transitive. If a relation satisfies all these three relations, then the relation is said to be equivalence relation. Is it clear? Then the relation is said to be equivalence relation. Understood? So to prove an equivalence relation, we have to first of all prove all three relations on a given relation कि वो reflexive है, symmetric है, transitive है. If a relation satisfies all these three, then a relation is said to be an equivalence relation. Now we'll pick up the examples, then these concepts will be more clear to everyone.